Good afternoon, students. Today I am going to start with a new chapter, that is solutions. This is the very important chapter in the physical chemistry, the second chapter of physical chemistry. Okay, after suggested, this is important. Okay, so students, in this 1 mark, 2 questions are there. 2 mark, 1 question. 5 mark, 1 question. Total it carries 9 marks. Understood? 1 mark 1 question, 2 marks 1 marks 2 question, 2 marks 1 question, 5 marks 1 question. This is question number 1 and 2. Okay, this is question number 12. This is question number 28. Okay, so this chapter carries 9 marks. So 1 mark question is there. That means very important chapter, because if you lost 1 mark means you won't get out of it. Okay, so students, in this, what I am going to say is, so listen. The solutions means, in our body, in our daily life, whatever may use, that is maybe a solid solution, or a bronze may use means that is a mixture of some of the metals. Solid solution. What is solution means? The homogeneous mixture of 2 or more compounds and 2 or more components called solutions. In our daily life, we most preferably use homogeneous solutions. Okay, the mixture of the compounds is same. So here what happens? So listen, if solutions are there, homogeneous is there, that solution consists of what? Solution means solvent plus solute. Solution means what? Solvent plus solute. Okay. So what is solvent here? So solvent is the component present in solution or a component major proportion of the component, or in the solution which was present in a bulk concentration, that is called as solvent. So this is less concentration or less quantity. If the concentration of the is more bulk in the solution, then it is said to be what? Solvent. If it is in less concentration, then it is said to be what? Solute. So students, here, what is solvent? So I will say one example for you. So listen, here salt is there, water is there. So in 1 gram of salt in 1 liter of water gives salt solution. This is solvent because it present in high concentration. This is solute. Okay. So same idea. This is salt. This is water. This is 1 g. This is 10 ml. Then also this is salt solution only. But here this is solvent. So this is not that perfect, it cannot be happen, students, but simply I am explaining you what is solvent and what is solvent. So if water is there, salt is there, its concentration is less. In a solution, if any one of the component is less in concentration, then it is said to be solute. If any one component is higher in concentration, then it is called as solvent. So solution consists of solvent and solute. So in this chapter, students, we are going to study only about the solutions of 2 components, that is binary solution, only liquid solutions, their formation we are going to study. So what are the objectives of this chapter is? What are the objectives? What we are going to study in there is, the first one describes formation of solutions, especially binary solutions. Okay, and a formation of solutions and its types. Next, second one is it explains about concentration of solution. Concentration of solutions, that may be molality, mole fraction, mass percent. Okay, that type of concentration terms we are going to study here. Okay, so next one is Henry's law, Raoult's law, Henry's law, Raoult's law. Next, okay, Henry's law and also Raoult's law. Next, difference between ideal and non-ideal solutions. Difference between ideal and non-ideal solutions and their graphs. In this chapter, graphs are very important. Okay. Next one is colligative properties. Next, abnormal behavior of colligative properties. This we are going to study in this chapter solutions. It describe the formation of solution, explain the concentration of the solution, Henry's law and the Raoult's law, difference between ideal and non-ideal solution, and the graph, how they varies with the temperature, how they varies with the pressure, and also colligative properties and abnormal behavior of the colligative properties. This we are going to study in this entire chapter. So we will discuss from one by one. That describe the formation of solution and its types. Okay. So students, so explain here types of solutions. Types of solutions. In that, gaseous is there, liquid is there, solid is there. Gaseous, liquid and solid solution. Here, solute particle, here, solvent particle. Here again types are there. Here solvent is gas only. Okay, if gas is a solute, then this is gas solution, then liquid gas solution, solid gas solution. I'll write example, then you came to know. Again, normal case, liquid is the solvent here. Here gas liquid solution, liquid solution, and this one is solid liquid solution. Okay, and next solid is the solvent here. So this one is gas, liquid and solid. So I will give some examples, students. You will understand what is the what is this type of solutions. Okay. So here for this gas solution, that is O2 in N2 gas. So solute, one of the gas is a solvent. So O2 in N2 gas represents what? Gaseous solution. Solute is also gas, solid is also gas. Okay. So liquid gas solution. Solvent is what? Solvent is gas. The more number of gas is there, and solute is what? Liquid. So here for this chloroform in N2 gas. Here, chloroform is a liquid. Liquid solute is dissolved in what? Into gas. Okay. So, and for this, camphor into gas. So, this camphor is solid, that is solute. Into gas is a gas, that is solvent. Okay. This is example for what? Gas solution, chloroform gas solution, sorry, liquid gas solution and solid gas solution. And here all the solvents are gas, means these are called as what? Gaseous solutions. So the next one is gas. Here solute is gas, solvent is liquid, that is O2 dissolved in water. That is oxygen, H2O, hydrogen is also there, oxygen is also there. Is either hydrogen dissolved in water or oxygen dissolved in water is the example of gas liquid solution. Okay, so you know biological oxygen demand which we require for aquatic animals, which is less than 5, correct? So that is what the O2 dissolved in water gives gas liquid solution. Next, liquid. Ethanol in water. Ethanol in water. So solid liquid means that must be solid. It must be a salt solution, sugar solution, or glucose. Salt solution or a sugar solution or a glucose dissolved in water. Okay. So in gas solid means this is hydrogen gas in palladium. Okay, so palladium is a catalyst, hydrogen gas is just plain strong catalyst. So hydrogen gas, this is the solute, and palladium is a solvent. So gaseous solute dissolved in solid substance example is H2 gas in palladium. Next, liquid solid, mercury with sodium called sodium amalgam. Sodium amalgam. Mercury with sodium results in sodium amalgam. So students, they may ask the question, what type of solutions called as amalgam? So solute is in liquid state, solvent is in solid state, then it is said to be what? Amalgams. Okay, zinc amalgam is there, mercury amalgam, sodium amalgam is there. Or any metal mixed with that mercury means they said as amalgams. So solid means it is copper with gold. You may take alloys. Any alloys are the example for solid solution. So all these solutions are homogeneous solution. That means they have uniform concentration throughout the solution. So students, these all the solutions what I wrote here have uniform concentration throughout the solution. Hence they are said to be what? Homogeneous solution. So only homogeneous solution we are going to study in this chapter. So what happens if heterogeneous, assume a mixture of some two different seeds. Okay, ragi is there, jawar is there. If you mix both of them, you may distinguish what is. You may separate the layer by any physical process like filtration or separation. Okay, so by that you may distinguish them. But it is in the uniform or homogeneous solution, you never separate solute and a solvent without any external process. Okay, we physically cannot separate out the solute and the solvent process either by filtration or any other physical methods. By chemical methods or by heating, by applying some chemicals, we can separate them solute and the solvent further. So these are what types of solutions. Solute is in this phase, solvent is in this phase. Then these are the example. This chart is very important for 1 mark. Okay, remember I told you question number 1 and question number 2, they last from this chapter. This chapter is important for this chart is important for 1 mark. Okay. So the next one is concentrations in solutions. Next one is concentrations in solutions. I'll write here student whatever concentrations are there, that is mass percentage. Okay. Next, volume percentage, mass per volume percentage, mole fraction, molality, molality. So these are all the concentration terms which we are going to use to tell about the concentration of the solution. Okay, students, all these depends on what? The solute and the solvent concentration. If the solute concentration is this x gram of solute dissolved in 100 ml of water means it gives x moles of the respective solution. Okay, this is the way. So these all the concept or concentration terms depends on what? The concentration of solute and the solvent particles in the solution. Okay, I'll explain one by one. So in that first one is students, that is mass percentage. Mass percentage. These formulas are very important. Based on this formula, students will get 1 mark, 2 marks question problematic. Okay, so they never ask they ask formula, they ask definition, or they ask problem based on the formula. So what is mass percentage? So listen, it is mass of the component divided by mass of the solution. Mass of the component into mass of the solution divided by mass of the solution into 100%. So this is the formula. So definition means, so what is mass percentage? It is the ratio of mass of the component present in solution to the mass of the total mass of the solution multiplied by 100. So this is the definition. So it is the ratio of mass of the component present in the solution to the total mass of the solution multiplied by 100. So this is the formula. Mass percentage is equal to mass of the component in the solution by mass of the solution into 100%. So what is to 10 students? So listen, if 10% of glucose solution has 10% of aqueous glucose solution means 10% of aqueous glucose solution means 10 gram of glucose dissolved in 100 ml of water. Understood? Not 1000. If it is compared with 1000 means that gives molarity. Here we are taking mass percentage. Percentage means it's with what? That with respect to 100 we have to calculate. So 10% of aqueous glucose solution means 10 gram of glucose dissolved in 100 ml of water. Similarly, 20% NaOH means 20% of NaOH dissolved in 100 ml of water. I hope you understood. So this is what? Mass percentage. Okay. Next one is volume percentage. Same. You are going to take volume percentage means nothing changes here, students. Only the volume changes. Here volume percentage means here volume of the component to the volume of the solution into 100. Okay, here what happens? It is defined as ratio of volume of component in the solution to the volume of or a total volume of the solution multiplied by 100. So students here, what they are given? Volume of the component divided by volume of the solution into 100%. Here, assume so 10% of ethanol in water means. Okay. So here what happens? This is alcohol solution or a water solution of ethanol, we may say. So 10 ml of ethanol dissolved in 90 ml of water, or you may say both water and this ethanol makes 100 ml with compared to what? The 10 ml is ethanol, remaining is water. Okay, so 10 ml of ethanol and the total volume of the solution is 100. That gives what? The volume percentage. This is the example. 10% of ethanol in water means 10 ml of ethanol dissolved in 90 ml of water. So students, why we are taking here ml? Why before we taken as gram means for solid substances we consider the solids never be measured in volume and liquids never be measured in mass. Okay, we may convert them. Okay, for example, listen, H2O is there, it is 100 ml for one mole consists of, I told you, 1 mole is equal to how much? 22,400 ml. So 1 mole of H2O2 means 1 mole of H2O means 18 gram. So 18 gram consists at present 22,400 ml means for 100 ml how much? Like this we can convert, students. Okay, we can get the mass of the liquids by comparing with the standard values. But basically, if you want to add a water or a liquid means we consider them in what? Ml, like 10 ml, 20 ml, 100 ml, liter. Okay, in grams means, sorry, if solid substance is means that never be taken in our volumes. Okay, they cannot be measured by measuring cylinders. They simply weighed on a weighing box. Okay, so what happens there? We can get the solids like, or we can weigh solids using weight. Okay, like gram, kg, gram, milligram, like that. So that's why for solids we use mass percentage. For liquids we use volume percentage. If solid is a solute and liquid is a solvent, then we use mass volume percentage. Mass volume percentage. What is the difference here? So mass of the component presenting volume of the solution into 100. So it is the ratio of the mass of the component in the solution to the total number of the solution multiplied by 100, that is called as what? Mass volume percentage. So for example, students, if they give 10 ml of, sorry, 10% aqueous, 10% aqueous sodium chloride means 10 gram of sodium chloride NaCl in 100 ml water. So your solvent is in volume, solute is in gram. So this gives what? Mass volume percentage. So another one is there, students, that is if the solute concentration is very less. Okay, if the solute concentration is very less, then this will represented by ppm, that is parts per million. What it is? So if the solute is very minute, then number of components in the solution divided by total number of component of the solution into 10 to the power 6 ppm. So this is what? Parts per million. So why when we will use this? If the solute particle is very minute, okay, less than milligram, then we will use parts per million, that is ppm. That means what? The ratio of number of components in the solution to the total number of components in the overall solution multiplied by 10 raised to 6. Why? Because we are comparing them with the million, 10 lakhs. Okay, so this is all about the concentrations with respect to mass, volume and all. So remaining is, students, that is mole fraction, molarity and molality. And explain what is mole fraction. What is mole fraction? Okay, so students, mole fraction means number of moles of component to the total number of moles of components present in the solution. And right, first, mole fraction means number of moles of one component. Because solute is there, solvent is there, we can check the mole fraction for solute as well as solvent. Okay, so number of moles of one component to the total number of moles of components in the solution. This is called as what? Mole fraction. So students, here, you know, this mole fraction is represented by X. This number of moles is represented by N, ARB, and this is Na plus Nb. N is represents number of moles, ARB represents any one of the compound, Na plus Nb represents total number in the solution. So listen, if A is the solute, B is the solvent, forms AB solution. This is N moles, this is N moles, this is also N moles. Okay, so here I write, if we want the mole fraction of solute, then Na divided by Na plus Nb. If we want mole fraction of solvent, then it is Nb divided by Na plus Nb. So I told you number of moles of one component, either solute or solvent, to the number of moles of components in the solution, that is both solute and the solvent. So this gives what? Mole fraction. Understood? So this is what, student? For example, and take H2 plus N2 gives rise to NH3. This is how much? 3 moles. This is 2 moles. So this is the solution. 2 moles of NaCl and 2 molar H2O gives 2 molar NaOH. Assume, just I am telling. So listen, if you want to check solute, this is solute, this is solvent. So this is 2 moles divided by 2 plus 2 means 4 moles. This is 2 moles divided by 2 plus 2 means 4 moles. This gives the mole fraction of the solute. This gives the mole fraction of the solvent. That's what I am telling students. If in the solution, both solute is there, solvent is there. So how many moles of solute present in how many moles of solvent gives the total number of the solution. That ratio gives what? Mole fraction. Okay. So the next one is molarity. I think you are well known about molarity. So number of moles of solute to the total volume of the solution in 1 liter, not total volume of the solution in 1 liter. Volume of the 1 liter solution. So next, it is defined as students. It is defined as the number of moles of solute dissolved in 1 liter of the solution. Instead of 1 liter, you may use 1000 ml or 1 dm3, 1000 cm3, whatever the way you want. Okay, it is defined as the number of moles of solute dissolved in 1 liter of solution. So that is called as what? Molarity. The number of moles of solute dissolved by volume of solution. This is the unit of molarity is capital M. So for example, students, if they has 0.2 moles of KCl or aqueous acid means, so in 1 liter of water 0.2 mole of KCl is dissolved. KCl, I will take 2 moles. I will write 2 moles of KCl is dissolved. So KCl means, you know how many grams? We didn't get them as a 2 moles. So 1 mole is of KCl is equal to how much? 739 plus 35.5 means 74.5 grams. So 2 moles means into 2, that is we will get 149 grams. So if 149 gram of KCl is dissolved in 1 liter, that gives 2 moles of this KCl solution. This is called what? The molarity. Number of moles of the solute present in 1 liter of the solution. If I am giving this example, 2 mole of KCl. So 2 mole of KCl means this much gram, 149 gram. If 149 gram of KCl is dissolved in 1 liter, that gives what? 2 mole of the solution. If you want to check it means, instead of KCl you take NaCl. Na means 23, Cl means 35.5. That is, or you take NaOH. You can easily understood. This is 23 plus 1, 24 plus 16, 40 gram. Okay. 1 mole means 40 gram in 1 liter. 2 mole means 80 gram in 1 liter. Okay, so 0.1 mole means 4 gram in 1 liter. I hope you understood. 1 mole, if you want to convert it into 0.1 means this is multiplied by 10 means this is also multiplied by 10. So 1 divided by 10, 0.1. 40 divided by 10, 4. So for 0.1 mole, we need 4 gram dissolved in 1 liter. So 0.2 mole means 8 gram in 1 liter. So this gives what? Number of moles. So molarity means number of moles of solute to the volume of the solution in 1 liter. Okay. So this is all about what? Molarity. So last one concentration is there, student. That is molarity. Okay, what is the difference between molarity? Molarity means here I will write number of moles of solute to the mass of solvent in kg. Okay, so students, it is defined as number of moles of solute dissolved in 1 kg of solvent gives molarity. Okay, so this molarity is of the unit small m. Okay, here what happens? It is defined as the number of moles of solute dissolved in 1 kg of solvent. So that means, students, if 2 mole NaOH solution, that is aqueous is there. Now you have to say, instead of ml, you have to convert it into what? Kg. How else? So 2 moles of NaOH, or you remember? 1 mole enough? So 1 mole of NaOH in 1 kg of water. In 1 kg of water. So 1 mole means 40 gram. 40 gram of NaOH in 1 kg of water. Okay. So we have to convert it into 1 kg students. How water 1 kg solution? 18 gram is equal to 1. Okay. To convert it into 1 kg, we want how many number of moles. Then we will get 10 to the power of 3 divided by 18 means we have some value, that is x value. So this is what 1 kg of water. Okay. So this is our course, students. Are you may check? So listen. 1000 ml of 22,400 ml of water is equal to 18 gram. So we want 1 kg means we have to get some value. That value is the water. That is how much? X is equal to 22,400 divided by 18. Okay, we will get some value here, students. If we dissolve that much of ml of water, so I will calculate here. 2 9s are 9, 3 left, 2 left, 24. Okay, assume this much. 1000. Okay, so 1866 ml. I hope you understood. If 40 gram of NaOH is dissolved in 1000 ml, that gives molarity. If 40 gram of NaOH is dissolved in 1866 ml, that gives what? Molarity. What is this 1866 ml? That is 1 kg of water. I hope you understood, student. So, it is one number of mole of solute to the mass of the solvent in kg. Here we are dissolving in water, but that concentration is changes to what? From gram, volume to gram. Okay? From before for molarity we consider ml. For molarity we are considering what? Kg. I hope you understood. So right here you understood the difference. Just now I calculated 1866 gram gives 1 kg of water. So listen, 40 gram of NaOH in 1000 ml of water. So that is 1 mole. That is capital M. Correct? So 40 gram of NaOH in 1866 ml. So this is how much? 1 kg of water. That is 1 mole. I hope you understood the difference. Here we are considering what kg, here we are considering ml. ml and kg is somewhat different concentration terms. So students, so you be thorough with the formulas of all these: mass percent, volume percent, mass by volume percent, mole fraction, molarity and molality. In tomorrow's class, we will discuss some numericals based on these formulas. Okay, thank you.